Imagine discovering that almost everything humans know today about Earth's climate, oceans, atmosphere, forests, ice, deserts, and even natural disasters did not come from the ground beneath our feet, but from silent machines orbiting hundreds of kilometers above our heads, machines that never sleep, never blink, and never forget. Because satellites have fundamentally changed how scientists understand the planet, revealing truths that were impossible to see before humanity left Earth's surface. And the most important thing about these discoveries is that they are not opinions, guesses, or theories, but measurements collected over decades using physics, mathematics, and direct observation from space. Long before satellites existed, scientists relied on ships, weather stations, balloons, and ground surveys, which provided useful but limited information, often biased toward populated regions and leaving vast areas of Earth completely unmeasured, especially oceans, polar regions, dense forests, and remote deserts. But the moment the first Earth-observing satellites entered orbit, scientists gained something revolutionary, a complete, global, continuous view of the planet as a single interconnected system. One of the earliest and most important findings from satellites was that Earth's atmosphere is far thinner and more fragile than it appears from the ground, appearing as a delicate blue layer hugging the planet, a discovery that immediately reshaped atmospheric science and showed how vulnerable life is to changes in temperature, chemistry, and radiation. Satellite instruments measuring carbon dioxide, methane, and other greenhouse gases revealed that these gases were increasing steadily and globally, not just near cities or industrial areas, but across the entire planet, including over oceans and uninhabited regions, proving that climate change was not a local phenomenon, but a planetary one. Over decades, satellite data showed clear trends: rising global temperatures, shrinking ice coverage, warming oceans, and shifting weather patterns, all measured independently by multiple satellite systems using different techniques, such as infrared sensing, microwave radiometry, and laser altimetry, providing strong scientific confidence in the results. One of the most visually striking discoveries made by satellites was the rapid melting of polar ice, particularly in Greenland and Antarctica, where satellites detected not only surface melting, but also thinning ice sheets, accelerating glacier flow, and massive ice loss into the ocean, something ground expeditions alone could never measure at such scale. Satellites measuring gravity changes showed that entire regions of ice were losing mass year after year, confirming that sea level rise was not hypothetical but already happening, with precise measurements showing millimeter-level increases globally. Satellites also transformed ocean science by revealing that oceans are not static bodies of water, but dynamic systems with complex currents, temperature gradients, and energy exchanges that regulate Earth's climate. From orbit, scientists discovered vast heat transport systems, such as El Niño and La Niña, which shift warm water across the Pacific and influence weather worldwide, causing floods, droughts, and storms thousands of kilometers away from their origin. Satellites measuring sea surface temperature, ocean color, and height revealed changes in phytoplankton populations, microscopic organisms that form the base of the marine food chain and produce a significant portion of Earth's oxygen, showing that ocean ecosystems are sensitive to temperature, nutrient availability, and pollution. Another major satellite discovery was the scale and speed of deforestation, as orbiting sensors revealed that forests were disappearing far faster than ground reports suggested, particularly in tropical regions where clouds, terrain, and remoteness previously hid illegal logging and land conversion. Time series satellite images allowed scientists to track forest loss year by year, linking it directly to changes in rainfall patterns, carbon storage, and biodiversity loss, and demonstrating that forests play a critical role in stabilizing climate and water cycles. Satellites also uncovered the surprising extent of desert expansion, as arid regions slowly spread due to changing precipitation patterns and land misuse, affecting agriculture, water availability, and human migration. In agriculture, satellites revealed that crop productivity varies dramatically with soil moisture, temperature, and weather extremes, enabling scientists to predict food shortages, drought risks, and famine conditions months in advance, saving lives through early warning systems. One of the most unexpected findings from satellites was how interconnected Earth systems truly are, showing that changes in one region can influence distant parts of the planet through atmospheric circulation and ocean currents. For example, satellite data demonstrated that dust storms originating in deserts can travel across oceans, fertilizing rainforests with essential minerals, linking arid and lush ecosystems in ways scientists
never imagined before space observation. Satellites also revealed how human activity alters the planet's night environment, with global nightlight data showing the spread of urbanization, energy consumption patterns, and economic growth, while also highlighting regions with limited access to electricity. These observations allowed scientists to correlate development with environmental impact, revealing both progress and inequality on a planetary scale. Another critical discovery made by satellites involves Earth's water cycle, as orbiting sensors measured rainfall, evaporation, snowpack, and groundwater changes globally, revealing that freshwater resources are far more unevenly distributed and vulnerable than previously thought. Gravity measuring satellites detected groundwater depletion in major agricultural regions, showing that underground water reserves were being drained faster than they could naturally recharge, a hidden crisis invisible from the surface. Satellites also transformed disaster science by allowing scientists to observe hurricanes, cyclones, wildfires, floods, and volcanic eruptions in real time, leading to a deeper understanding of how these events form, evolve, and intensify.
From space, scientists discovered that hurricanes draw energy from warm ocean water and can rapidly strengthen under certain conditions, leading to improved forecasting models that now save countless lives. Wildfire monitoring satellites revealed that fire behavior depends not only on vegetation, but also on wind patterns, terrain, and atmospheric stability, changing how fire risks are managed worldwide. Volcanic monitoring from orbit showed that many volcanoes subtly deform before erupting, allowing scientists to detect magma movement and issue early warnings. Satellites also revealed changes in Earth's magnetic field, measuring slow shifts caused by movements in the planet's molten outer core, data that helps scientists understand Earth's internal structure and protect satellites and power grids from space weather effects. Space-based observation of solar storms showed how bursts of charged particles from the sun interact with Earth's magnetic field, disrupting communications, navigation systems, and electrical infrastructure, leading to better forecasting and technological protection strategies. Another major revelation from satellites was how rapidly Earth's surface can change due to earthquakes, as radar satellites detected ground displacement down to centimeters, even in remote regions, helping scientists map fault lines and understand tectonic stress buildup. Satellites also exposed large-scale pollution patterns, tracking nitrogen dioxide, sulfur dioxide, and fine particles in the atmosphere, revealing that air pollution travels far beyond city borders and affects global health, ecosystems, and climate. Ocean-observing satellites detected massive plastic pollution zones and oil spills, showing how human waste spreads across marine environments and persists for decades. Over time, satellite records became one of science's most powerful tools because they provide consistent, long-term data sets, allowing scientists to distinguish natural variability from long-term trends. This long view revealed that recent changes in temperature, ice loss, sea level, and atmospheric composition are occurring much faster than most natural changes observed in Earth's history, strengthening scientific conclusions about human influence. Satellites also revealed that Earth systems can respond rapidly to reduced human activity, as seen during temporary global slowdowns when air pollution levels dropped noticeably, demonstrating both the scale of human impact and the planet's potential for recovery under the right conditions. Importantly, satellites showed that Earth does not have clear boundaries between land, sea, and air, but rather continuous exchanges of energy, matter, and momentum, meaning that environmental problems cannot be isolated or solved locally without considering global interactions. Beyond Earth observation, satellites also transformed navigation, timekeeping, and scientific coordination, providing precise timing signals essential for research, communications, and financial systems, demonstrating how deeply space technology is woven into modern civilization. Scientists analyzing decades of satellite data emphasize that one of the most profound discoveries is not a single phenomenon, but the realization that Earth behaves as a complex adaptive system, sensitive to small changes and capable of rapid transformation. Satellite observations have repeatedly corrected assumptions made from limited ground data, forcing scientists to revise models, improve predictions, and acknowledge uncertainties honestly. Importantly, satellite data is continuously cross-checked, calibrated, and validated using independent instruments and ground measurements, ensuring scientific reliability and minimizing bias. These findings have reshaped policies, international agreements, and environmental monitoring programs, not because satellites tell stories, but because they provide measurable evidence. Satellites have shown that humanity's footprint is visible from space, not through dramatic destruction alone, but through subtle, cumulative changes that add up over time. They have also shown that Earth remains resilient in many ways, capable of regeneration when pressures are reduced, offering scientific hope grounded in data rather than wishful thinking. Ultimately, what satellites have really found is not just information about Earth, but a new way of understanding reality, one where global observation replaces local assumption, long-term measurement replaces short-term perception, and evidence replaces speculation. Satellites did not make Earth fragile. They revealed that it always was, and that its stability depends on balanced interactions between atmosphere, ocean, land, ice, and life. And perhaps the most important truth satellites have given scientists is perspective, the understanding that Earth is not an infinite resource, not a collection of separate systems, but a single shared environment whose future depends on knowledge, responsibility, and decisions guided by what space has allowed us to see with clarity for the first time in human history.